Hi, this is Saka again, and here I'm going to try and help you with the 9.4 homework. Okay, so here I'm looking at question 1, and here we have our phase diagram here. And so the first question asks, well, the first few questions deal with this phase diagram, but basically what they're asking us here is, you know, if we're at 10 degrees, which is about here, and 20 atmospheres of pressure, which is about here, so I'll plot it like right about here. Oops, I put on my pen here. So if we're at 10 degrees and 20 atmospheres, we're somewhere in this region here. So they're asking you what state of matter. So when they give you pressures and temperatures, all you need to do is basically just plot the 2 points and figure out where you are on the phase diagram. So that's how you do number 1. And you can look at the state of matter that goes along with it. For number 2, now we're at 50 and 0 atmospheres. So again, 0 atmospheres? Yeah, so 50 degrees and 0 atmospheres. And so you'd have to find again yourself on the graph. So 50 degrees would be about here, and 0 atmospheres would be like around here. So you can kind of read the graph and kind of figure out where you'd be next. Okay, and then for number 3, they ask you a question, one of the key terms. I figure you know what that one is. And it's pretty much going to be labeled on any phase diagram. Okay, and then it says here for this fourth question, a sample of ice is at 1 atmosphere and 0 degrees, and the pressures increase while the temperature is constant. What happens to the ice? Well, when we're looking at this, oops, not the eraser. If we're at 0 degrees and 1 atmosphere, we're probably somewhere like right around here. And if we increase the pressure while the temperature is constant, you can see you end up passing into that water region. So going from solid to liquid is what process, and I'll let you figure that one out. For number 5, you're looking at intermolecular forces, and so we have the 3 intermolecular forces. Remember we have it's really skinny. The 3 intermolecular forces we have. Let me just increase this a little bit, make it a little thicker. The 3 intermolecular forces we have here is we have London dispersion, we have dipole, and we have H bonding. Okay, so remember, London dispersion, both polar and nonpolar will have London dispersion forces. Dipole interactions are for polar covalent compounds only, and hydrogen bonds are for polar covalent bonds only. Now when you have a polar compound, it's either going to be London dispersion and dipole, that looks horrible, or you're going to have London dispersion and H bonding. Okay, now remember, for H bonding, you have to have H bonded to either O, H bonded to F, or H bonded to N for it to be hydrogen bonding. If H is bonded to anything else, it's got to be dipole. And so hopefully that'll give you enough information for you to figure out question 5. Let me erase. In question 6, the boiling point of HF is high because of hydrogen bonds. What are the characteristics of fluorine that enable it to form hydrogen bonds? Well, remember the fact that if it's hydrogen bonds, we're talking about polarity. Polarity, not with an I. And if we're talking about polarity, we're talking about a difference in electronegativity. Okay, that means that you have to have something with high electronegativity combining with something with low electronegativity. So you have to decide what, how that fits for fluorine. Okay, let me scroll down to question 7. Here we have a figure and we have to identify the hydrogen bond. So let's see here. You remember an H bond is an intermolecular force. So it should be something that occurs between two different molecules. And remember, a hydrogen bond more specifically is when H from a polar bond is attracted to an unshared electron pair from a polar atom. Okay, so hopefully that's enough information for you to be able to identify that. Okay, moving down to question 8. Okay, this one's kind of tricky. So here they're asking for the strongest bond. So remember, you have your intermolecular forces. Oops, that isn't good. Intermolecular. And remember, intermolecular forces are things like London dispersion, dipole-dipole, and H bonding. Oops, H bonding. Intramolecular forces, are things like ionic bonding and covalent bonding. And remember, with intramolecular, covalent could be either polar or nonpolar. Now remember, this says the strongest bond. It doesn't differentiate between intermolecular or intramolecular. Intramolecular are always stronger, the strongest bonds. It doesn't matter, even though hydrogen bonding is the strongest, it's the strongest intermolecular force, but hydrogen bonding at its finest is not going to be stronger than intramolecular bonding. And hopefully that'll help you with question 8. Question 9. Here they ask you, they look at these two things. Now, if you look at this one, A is nonpolar, B, because of this F, is going to be polar. Now remember, the stronger the IMF, that means that the boiling point would be higher, the melting point would be higher, the vapor pressure would be lower, and the viscosity would be higher. So hopefully by identifying things as nonpolar and nonpolar, you can identify the intermolecular force and then hopefully be able to figure out what corresponds to that property. Okay, moving right along down to 10 now. So here we have another phase diagram. This one is for carbon dioxide. So we're at 1 atmosphere and negative 78.5 degrees. So what happens is we raise the pressure while keeping the temperature constant. So what happens? So that basically what that means is we're going straight up. And so what ends up happening is you see that you can follow the red line and kind of figure out what happens there. And let me erase that. And let's scroll down to 11. 11, here we have the phase diagram again. We have carbon dioxide at 10 atmospheres and negative 56.4 degrees. And this sample is constantly heated until 32 degrees while keeping the pressure constant. So if we're at 10 atmospheres and negative 56.4 degrees, we're probably somewhere, I don't know, somewhere about here maybe. And we would keep increasing the temperature until 32 degrees. So here we go. And so 32 degrees is probably somewhere a little bit past here. So now instead of going up, we're going across here. And so again, you can follow this region. You can see here we'd probably maybe start as a maybe a solid, I would say, and then all of a sudden, oops, and then we would go from there. And you can follow the line to kind of see what phase changes occur for that one. For 12, we have water is a polar molecule. Okay, so which of the following would mix with water and not dissolve? So remember, like dissolves like. You probably remember this from biology, right? What that means is since water's polar, you're trying to figure out which one of these, which one of the choices is polar out of these choices. Which one is it? Okay. And there could be more than one. And I see two, so there's a hint. But look at these structures and try and figure out which ones would be polar versus which ones would be nonpolar. Okay. Moving down to 13. Which of the following best explains why the melting point is higher? Okay, so remember we talked about intermolecular forces, right? So the stronger the intermolecular force, the higher the boiling point. So you have to decide what intermolecular forces hold up ICL versus BR2. And so you can start with polarity, and then once you find out whether or not it's polar or not, you can identify the intermolecular force. Okay, so that should help you with 13. And then for 14, so here we're looking at 14, the last one. So the boiling point is blank versus blank. So you have to look at CH4, and you have to look at HF, and then first thing you have to do is again polarity. So yes or no for each one of these, and then the intermolecular force that holds them together. So hopefully you have enough information here. We've done enough practice, and you've seen these molecules enough time to hopefully identify whether or not each of these molecules is polar, and then once you find that, what intermolecular forces. Okay, and then remember, whichever one has the stronger intermolecular force, that will have we've talked about the properties before, right, in terms of boiling point, melting point, vapor pressure, and viscosity. So good luck, guys. That is it.